Hello, welcome to today's session. First of all, if you have any doubt regarding this session's lectures, please do ask. Any question do you have regarding this week's lectures? Please ask if you have any doubts. Okay, so let's start with the questions then, if nobody has any doubt. So let's start with this basic question. So we have a phasor 5 cos 2 pi 60t plus pi by 3. Please, if you have a pen and paper, please draw the phasor on your copy and show it through the camera. Five cos 2 pi into 60t plus pi by 3. Am I audible? Hello? Okay, so let's go to the question. So this is a phasor 5 cos 2 pi 60t plus pi by 3. How will you draw a phasor? Okay, you need not draw it on paper, and just say it out. How will you approach in drawing a phasor? you can comment in the chat box as well. So the question is, there is a phasor 5 cos 2 pi 60 t plus pi by 3. How will you draw a phasor on a paper? Anyone? Yes, Bharat, you wanna try?
Sir, amplitude, we start drawing a phasor diagram by taking the amplitude of the waveform as 5.
Okay, we take the amplitude of the phasor 5. Okay, so we draw an arrow, right?
Yes, sir, and phase difference is 60 degree.
Phase difference is 60 degree with respect to a reference.
Yes, sir, with respect to our
reference phasor. Yeah, so this is our reference phasor. Okay, wait, my screen is not visible, I guess. I haven't shared the screen. Just a second. Now is the whiteboard visible?
Yes, sir, yes, sir.
Okay, so this is my reference phasor. And this is the phasor, and the phase difference is pi by 3 or 60 degrees. Pi by 3 radians or 60 degrees. Now what I have drawn now is just a vector. It is not a phasor. Now what comes when we define a phasor? Can anybody define what is a phasor? You can also comment in the chat box as well. Whatever you think, you just say it. What I have drawn here, it is actually a vector. So phasor is actually a rotating vector which has an angular velocity. So here we have angular velocity of how much? How much is the angular velocity? Anyone? How much is the angular velocity in this phasor? 120 pi. Okay, yeah, 120 pi, it's correct. So the angular velocity here is 120 pi rad per second. So phasor is a quantity that has an amplitude and a angular velocity. Okay, and vector is something that has a magnitude and a direction, but phasor is a quantity that has a magnitude and an angular velocity. So can anyone please repeat what is the difference between a phasor and a vector? Or type in the comment chat box what is the difference between a phasor and a vector. Hello, am I audible? So please say what is the difference between a phasor and a vector that I just now said. You can also comment in the chat box as well. Yeah, exactly. Vector is a quantity that has a magnitude and direction, and phasor is a quantity that has a magnitude and angular velocity. Okay, so this is something we should remember throughout the course. Okay, so the next problem, let's go to a next problem. This is a problem sheet on sinusoidal phasors and sinusoidal steady states. So I will be sharing this problem sheet in the link of my drive that I have shared in the course page, so you can access this problem sheet there. So today I will do some of the problems from this sheet. So next one is, let's do, okay, let's do this problem. Problem number 1. Suppose a current of 5 e to the power j pi by 3 is flowing through a conductor. So what do you make of this value 5 e to the power j pi by 3? What is it? So the question is current of 5 e to the power j pi by 3 ampere is flowing through a conductor. What do you make of this term 5 e to the power j pi by 3? What quantity is it?
Hello.
Yeah, go ahead.
Sir, it is an exponential quantity. We can convert it into Phasor form. Just e raised to power j pi by 3 means cos pi by 3 plus j sin pi by 3.
Exactly. But it is also Phasor. It is a different representation of Phasor only. It is Phasor quantity only.
Exponential representation of Phasor.
Exponential representation of Phasor. Exactly. So what we can do is we can write this as 5 cos of omega t plus pi by 3. Okay, any doubt? So this is another way of representing phasors. This is the exponential form of, this is the exponential form of phasor representation. This is cosine form. Phasor representation. Okay. Okay, so now we will move to a bit difficult problem. Okay, let's do this problem. This is the application of Kcl. So cos 2 pi 60 t plus 8. Cos this is my I1 current, and here I have the I2 current as 15. This is my I3 current. Find I3. Please do it now. What is the value of I3? Once you get the answer, please do comment in the chat box. Please do the problem, and once you are done, please comment on the chat box. So I just now gave a problem. So The problem is this is a line that is coming, and the current in this conductor is I1, that is 30 cos 2 pi 60 t plus 36 degrees, and this line is dividing into two lines. One line is carrying a current of I2 equals 15 cos 2 pi 60 t plus 225 degrees. So what, please find the value of I3. This is the problem. Anyone done with the question, or any confusion you have regarding solving this question? Please do ask. Okay, so can anyone please just state what is Kirchhoff's current law? What do you mean by Kirchhoff's current law? Just comment in the chat box. What do you mean by Kirchhoff's current law? Yeah, so the total current entering a junction or a node equals the charge leaving that node. Exactly. So this is basically law of conservation of charge. Right, Lokesh? Hello. Am I audible? Yeah, correct. Now, since you all know what is Kirchhoff's current law, so solve the problem. This is the problem. What will be I3? Anyone? Lokesh, Bharat, anyone? Oh yeah, sure. So you have one conductor that is carrying a current of I1 that is equals to 30 cos 2 pi into 60 into t plus 36 degrees, and this line is bifurcated into two lines. One is carrying a current of I3 which is unknown, and another is carrying a current of I2, that is 15 cos 2 into pi into 60t plus 225 degrees. Find out I3. Yeah, so you have an answer of I3 is 15 cos 2 omega. Omega is 2 pi into 60 plus 135 degrees. Okay, let's check. No, the answer is, so okay, so can anybody say what will be the KCL equation at this node? Let name the node A. This is node A. So what will be the KCL equation of node A? Anyone? Can you be a bit louder? Actually, I couldn't follow you. Or you can just comment in the chat box as well. Yeah, I1 equals to I2 plus I3. Let's write it down then. I1 equals I2 plus I3. So I3 equals I1 minus I2. So what we have is 30 cos 2 pi 60 t plus 36 degrees minus 15 cos again 120 pi t plus 225 degrees. So we can say 30 cos 120 pi t cos 36 degrees minus sine 120 pi t sine 36 degrees minus 15 cos 120 pi t cos 225 degrees minus sine 120 pi t sine 225 degrees. So now collecting the terms, we have under cos 120 pi t, we have here 30 cos 36 degrees minus 15 cos 225 degrees plus sine of 120 pi t 30 minus 30 sine 36 degrees plus 15 sine 225 degrees. Okay. So from here we can say the coefficient of cos 120 pi t is 30 cos 36 minus 15 cos 34.877 plus sine of 120 pi t. Okay, so minus 30 into sine 36 plus 15 into sine 25. It's minus 28.24 minus 28.24. So this can be written as okay, so this I can write as so the magnitude will be root over 34.877 square plus 28.24 square. It's 44.87 and cos of 120 pi t. Now what will be the angle? Angle will be plus tan inverse of minus 28.24 by 34.877. Hence the answer is 44.87 cos of 120 pi t minus 39 degrees. This is the answer. This is equals to I3. Any doubt? So yeah, Archana, it's not 15 cos 2 pi omega t plus 135 degrees, it's 44.87 cos omega t minus 39 degrees. Is it okay? Is there any doubt? Please do ask. Yeah, go ahead.
Sir, I want to ask you one thing. Sir, if we take a plain number and not a phasor quantity like I1 we take as 1 ampere, I2 take as 2 ampere.
Okay.
Then we have to find the I3, then answer will be equal to -1.
Yeah.
Because it satisfies the KCL. But in phasor form, whatever you have written the answer, does it satisfy KCL, sir?
Yeah, it always satisfies KCL. See, when we write phasor, when do we write phasor form? When we have sinusoidal current and voltage.
Yes sir, yes sir, yes sir.
So KCL is satisfied at every instant. It's instantaneous.
Okay,
And if you consider one instant, you will see at every instant KCL is satisfied.
Okay sir, okay sir, okay sir.
Okay.
Yes sir, okay.
Okay. Any other doubt? Anyone? Any doubt? Please do ask. Actually, I have done one mistake. Here it should be 44.87 cos of 120 pi t. It won't be plus, it will be minus. This will be minus and this will be plus. Can anybody say why? Anyone? Okay, so see, here we have cos of 120 pi t into 34.877. So this represents a phasor. How do we represent this phasor? This phasor is like this. This is the phasor. Magnitude is 34.877. And we have sine of 120 pi. So sine will be what did we say? We said that the phasor is always represented by magnitude and angular velocity. So it's 120 pi in this direction. So this is the cos part, and the sine part is minus 28.24 sine 120 pi t. How do we represent that? It will be represented by just a second. So minus 28. So minus 28 will be this side. 28 point. How much is also value? It's 28.24. And 24. So this is this part. So if you add them up, you get this quantity. This is the phasor sum. And this angle is 39 degrees. So since we are representing everything in terms of cos, the angle with respect to the cos component, that is this one, is opposite. So here we are representing the 39 degree with respect to the sine component. So that's why the negative sign. Any doubt? Lokesh, you have any doubt? Okay, so let's do a different kind of problem. Okay, are you familiar with the term phase sequence? leave it for now. Let's do another problem then. Okay. Let's consider a capacitor of 25 microfarad, and let's consider the voltage across it is V, where V is 40 cos 2 pi 60 t. What is the impedance of the capacitor? Anyone? Yeah, absolutely. Please do it. What is the value? Please tell me the value. That you need to find out. This is the question. What will be the omega? There is a hint. The voltage across the capacitor is being told to be 40 cos 2 pi into 60 t. If you are done, please do comment in the chat box. 1.851. Okay, let's see. So Evangeline, please to say what is the omega according to you. What omega you considered? Exactly 2 pi 60. So it will be 1 by omega. So it's 1 by omega 2 into pi into 60 into, what is the value? 25 microfarad. 25 10 to the minus 6. Yeah, the answer is 106.1. 106.1. Please do check out. This much ohms. Is it okay? Okay. So yeah, that's pretty much it, because this week's lectures are pretty simple this time. So there is nothing to do much in this week's course. So if you have any doubt, please do ask, or else we will end this session. If you have any doubt regarding this week's course material or anything, please do ask. Yeah, please go ahead. Please go ahead. Even please go ahead. Question number 8. Okay, let's see. So I shall give you the hint. Question number 8. We want. I can't show you this. Okay. Yeah, please go ahead. What is your doubt? Your voice is not clear. You just type in the chat box only. So this question, right? Is this the question? For two cases, yeah. VR and the load resistance is mentioned for two cases, and in the third case the resistance is being mentioned. You need to find out the voltage across it. Okay, so how to do it? So basically the question is just a second. Yeah, so the question is, when R is 10, VR is 20. When R is 20, VR is 30. So what do you make of it? when just read the first line, that when R is 10 ohms, when R is 10 ohms, VR is 20 volts. When R is 20 ohms, VR is 30 volts. So what do you make of it? Simply just, yeah,
it is changing with respect to time.
exactly, the voltage is not the same, it is changing with time. Exactly. So we can say that the black box is not an ideal voltage source. Can we say it or not?
Yes, sir.
Okay, so first things first, so we can say that this is my black box, we are representing it as DC network, and we are taking out a resistance R. So this voltage plus minus VR is varying.
So you're not showing this.
Oh, okay, just a second. Yeah, so this is the black box, and this is the external resistance, and this is the voltage. Now what we know is R is 10 ohms, then VR is 20 volts. Similarly, when R is 20 ohms, we have a VR of 30 volts. Now this makes it very clear that this DC network is not an ideal voltage source. Had it been an ideal voltage source, VR would have been constant. Yes or no?
Yes, sir.
Okay, so that we know for sure. So we know we have some voltage source V. We have something here. We don't know yet what we have. Again, we have black box and a resistance R. So now this, I have mentioned it to be a DC network, right?
Yes, sir.
So which components come in a DC network? There, okay, how many components are there in a circuit? Basic components, passive components, what are they?
Resistor, capacitor.
Resistor, capacitor and inductor. Okay, so under DC steady state condition, which of this component show up?
Resistors.
Resistor. Inductor and capacitor won't show up. They only show up, they only show their effect during the transient condition, right?
Yes, sir.
Okay, so now we know that this smaller black box, this portion will be some form of a resistive network. Yeah?
Yes, sir.
Okay, so we need to represent this in term of a resistor. Now can we represent it as a resistance in a parallel or in series? Which one we can represent and why?
Because voltage, sir.
Exactly, we have to represent it in series only. So it will be V, then a series resistance of small r, let's say, and load resistance of capital R. Why? Because if this we consider it to be in parallel, it would have again been an ideal voltage source, which is not in our case. So now we know that the network can be represented in terms of a voltage V in series with a resistance R. Now you have you can get two equations and two unknowns. You have V and R. Two equations you will get using Kirchhoff's voltage law. You have this loop, apply Kirchhoff's voltage law that you have learned in this week's course. Apply it and you will get the result. What is V and small r? Is it clear now?
Yes, sir.
Okay. Okay, no issue. Any other question? if you don't have any question, let's stop the session. So thank you all. And how was the session? Please do let me know.
The session was very good. Hello.
Okay. Yeah, Bharat.
The session was very good.
Okay, thanks. If okay, so yeah, if you don't have any further questions, you may leave the session. Thank you for all for joining this session.